All right, so this Achievable All-Star, Simple Robots That Win, they're kind of the same thing. There's been threads on Chief Delphi about it, but background on who I am. My name's Wes. I coach Team 1732. I joined the team as a student in 2011. That's me from 2012, roughly in the middle. I do design, mechanical, and strategy, as well as I'm the drive coach. And then in my free time, I'm a mechanical design engineer at Milwaukee Tool. I'm going backwards. All right, cool. So what is simple? People are debating, the definition of simple, basic, whatever. But there's a couple other topics, discussion right on the topic. 1678 gives a great presentation with like a bunch of world-class, world championship teams. That's probably better than this one, so you can check that out. That's on their website, as well as there's some discussion on Chief Delphi about other robots. So I focus this one on Wisconsin because hopefully it'll be teams that you all recognize or robots you've seen in the past. But what's simple for 254? Who knows what 254 is if I make those references? If you don't, they're number one. They're like the top bot. Maybe they don't win champs every year, but they're winning it like every other year almost at this point. So they're like really good. But what's simple for them is going to be different than what's simple for me. And what's simple for my team is going to be different than what's simple for next year's 10,000 level, rookie at the Wisconsin Regional, because we're in the numbers of 10,000s now, which is wild. But simple is about, to me at least, it's about building within your capabilities so that you can achieve your goals. But goals to each team is going to be something different, right? Some people want to just be better than they did last year, which may mean winning more matches. Maybe it's winning a judged award. Maybe it's, I put winning hearts. So that's like getting picked, right? If you want to get picked, or you want to be, right, like you want to show your school that you have a successful robotics program, or you want to win regionals or, off-season events or, something of that nature. So what I'm going to do is I'm going to go through a little bit of Wisconsin history on some robots that I thought, did a good job of going simple, but also were really successful. So first up, in 2016, I'll give a little overview what the game was too, since I know everyone here is, who's the oldest we have here on teams? They're like rookie year is 2021, 2022? Oh no.
Rookie year 2012.
Rookie year 2012. Okay, student-wise, but all right, good you guys. So we have some mentors with more experience. That is some point I was going to make actually. Some point in this is it's good to do research into game history, because teams who've been around a while, or at least have mentors who've been around a while, kind of have an advantage of knowing what robots did well way back when.
Kind of corroborating point, sorry to steal the spot.
No, it's all good.
But, we used a lot of aerial assistance. We had a lot of mentors who initially joined on the aerial assist year. So last year in particular, we used a lot of looking backwards at previous designs.
It's a great trick to use if you've got a certain game type or game element that is similar to a previous game element. What did robots do that year? You're not going to be able to copy it exactly usually, but you may learn something. So anyway, starting with 2016, we got UPS. Game that year is you had to put these boulders either into the high goal or the low goal, and you had to drive over these defensive elements that were on the field. What UPS did is they primarily focused on just scoring in the low goal. Which most times you think like, well, that's worth less points. Why would they do that? If you got a certain amount of points or game pieces in either the high or low goal, you got the ranking point, and that's super important for ranking high. If we're all familiar with how FRC games work in the current, FRC history. So they were able to put a bunch of game pieces in the low goal because they could do that fast. A lot of teams would miss when shooting up high, and they would waste time, but UPS could put a bunch in low, and then they were good at driving over some of the defenses, as they were called, and so they were able to, I think they were #1 seed. They picked the best, high shooting robot at St. Louis, and they won the event. They won the Imagery Award, and then they were also a captain of an alliance at Champs, which is incredibly hard to do. So I think they eventually, tried to shoot high later on in the season, but they did a good job starting simple. They ignored the high goal. They didn't climb. And I don't think they attempted to go over every single type of defense. There were like 10 different types of defenses, 9 different types of defenses that you could drive over, and they just focused on a subset of them so that they knew that they could be successful at what they did. I'm going to go kind of fast through some of these because I don't know exactly how long. We can have like a discussion at the end too, or go back and talk more about teams. But if anyone has questions, feel free to raise your hand and wave around in case I don't see you. All right, next year, 2017, we've got 2830. This is Riverside. They are what I call the unofficial kitbot of 2017. We're all familiar with the kitbot of this past year, and it didn't exist back then, but if it was, it probably would have been this robot. So game that year is you had these little wiffle balls. You had to put them in either a high goal or low goal. Low goal was just about worthless, and high goal was only worth it if you were really good at it. Sometimes you could break ties with it, if you got a couple in, but it was really hard to really make a difference in the high goal. The other thing you would do is you would take these yellow gears and you would place them on pegs, and you got kind of incrementally harder to get points. You got like points for scoring 1, points for scoring 2, points for scoring 4, and points for scoring 6. I think it was something roughly in that increment. But what they did is they didn't have any activating mechanisms. They just had a ramp that loaded from the human player, dropped it into a slot, and then they would go drop it off. And then the one thing that they did have that moved was they had a climber. But they ignored fuel, which were the balls in both high goal and low goal, and they just power cycled gears, and that led them to be the finalist captain of at Seven Rivers. They were the 2 seed, I believe.
The human player was on the field.
Human players on the field, yeah, that was like that's wild, right? So there's a big like structure in the middle, and you would put 2 of your human players up there, and they would like fish up the gears. It's good. I don't know if they're ever going to go back to that because it was it was definitely a fun year, but it was a massive obstruction on the field. So if your driver's station was in the middle, you were just like cut off from a huge chunk of the field. So that was one of the downsides. And then also it's a little bit of a safety concern, especially if you guys know how much damage the robots do to the field this year. Robots are getting faster, more powerful. So I'd imagine they'd be keeping human players off the field for the near future. All right, so another UPS reference. So this is a rebuild. So there's kind of 2 approaches you can to being simple. You could either start simple, or you can recognize that you went too complicated and then find a way to bring it back into scope. So at their first event, they had a shooter, they had a ground intake, they had something for placing gears, and they had something to attempt climbing, and none of them worked all that well together. And it's a bad image there because that's like the best one I could find of what it looked like before. I'm sure there's a better picture, but they went unpicked at St. Louis that year. They didn't get picked, and in between their events, they kind of took a step back and were like, we built something too complicated. We need to redo some of this. And so they took their shooter off, they took their intake off for balls, and they went with a simple 2-position gear intake and climber. They ended up being the first pick of the 4th seed at Wisconsin and went on to win the regional. So they did a good job, and this was before you had like, who knows what the bag means? People reference the bag. Yeah, just a couple of people reference the bag. So we used to have to bag the robot. At the end of 6 weeks, you put the robot in a big old bag, and you couldn't touch it until you went to the event. And then you'd have to bag it between events. So they had to, at home, prepare the stuff to put on, and then at the event, they spent all day Thursday tearing everything off, putting the new stuff on, and wiring up and everything. So it was a big undertaking that ended up paying off for them. Now the trick is, how do you realize you're going too complicated sooner? And I don't have an exact answer for that, but it's kind of what this discussion is meant to be about. All right, 2018. First one I'm talking about is Paradigm Shift. So they won 2 regionals that year as the 1st seed captain. Won the Innovation and Control twice. And so what a lot of like the high-end teams that year did, they either had some mechanism that like flipped the cube over the top of their elevator. They might have passed through their elevator. Let me back up and explain the game. You had these cubes, you had these scales on the field, and you basically had time-based scoring where if you owned the scale, you were getting 1 point per second. And so you wanted to put more cubes on your side of the scale so that you could maintain control of the scale. And then at the end, you could climb on this tiny little bar that's like this big. You guys know how big the chain is this year, right? It's like 3 robots wide. This is like half a robot wide. But you got more points the more robots were off the ground at the end. So teams figured out that they could lift other robots. They had little ramps that would drop down, or they had little bars, or they would physically like grab the other robot and lift him up. And that was hard to do. And so they skipped all of that. They just lifted themselves up. They made it, open for maybe another robot to kind of fit next to them. But otherwise, they just had a, front-facing intake. And I think the most complicated thing they did that year was the elevator would like tilt back to start the match and then tilt forward, and that gave them a little bit extra height. I was not on the team. I don't know if those are the reasons why they did those things. That's my assumption from looking back on it. But overall, right, they ignored the complicated handoff and pass through or robot geometry. They ignored buddy climbing. They went simple. They got their robot done early enough where they could get a lot of good practice, make sure all the bugs are worked out, and had a really successful year. At Wisconsin, their third robot, the second pick of the first seed, was Ferrodermis, and they built, I think it was one of the Robot in 3 Days robots that year. I don't know if anyone remembers. But again, they ignored climbing, but they also ignored the scale. So you had to be really tall to score up here, but they had short versions of these on either end of the field that were basically, each worth, you'd get points if you owned it, if you owned yours, but you wouldn't lose points, I guess, if it was going the other way. It was just like the other, it was kind of go neutral. But they focused on that, and then there is another way to score where you'd like put cubes in like a little slot at towards your driver's station. But that's what they focused on, and it got them picked, and they won the event. All right, we skipped forward a couple years because I couldn't think of a good one for 2019. I'm sure there's a great example for 2019. And then we had COVID, and then this robot that I know about. It's not the most simple robot, but I thought it was a good example because some of the teams that were in Einstein finals that year had turrets, they had double-sided intakes, they had sensors for detecting what color the balls were. Let me reset real quick. Oh no, everyone knows this game, right? Does everyone know this game? This is your freshman year at the most? Or actually, no, we got younger people than that. So you had red and blue balls, and depending what alliance you're on, that's the one you wanted to score. And you'd throw them up into this big funnel, and you got points for scoring them. There was like a short funnel for like a low goal, and then at the end there were like these monkey bars you could climb up, and you got more points the higher you climbed. But you couldn't just reach up and grab the tallest one. You had to grab one of the shorter ones and go up, unless you had like one of two really interesting mechanisms for kind of cheating around the rules. There's a robot that literally jumped off the ground and straight up.
I was in a presentation earlier. I hate to cut you off. But,
No, it's okay.
Yeah, I saw that. I'm like.
The jumping robot?
Yeah. Like,
it's wild. Look up jumping robot 2022. If we got time after this, we can pull it up. But that one's wild. That is not simple. They pulled it off because I don't know how they pulled it off. They've got someone who knows a lot about compressed air and how to be safe about it. But they did a good job with it. It was wild, but it was not the route that I would take if you're trying to go simple, because they had to build their whole robot around it. Anyways, so the teams that were like on Einstein had turrets. They had double-sided intakes. They could detect what color balls they're picking up and like shoot the wrong color ball in a corner, so it made it harder for your opponents to pick it up. They had mechanisms for climbing all the way to the top. What else? They had adjustable hoods, and we ignored a lot of that. We did fixed position shooter with a fixed shooter with a 2-position hood, and one-sided intake, and we only climbed to what was effectively the third level, but you grabbed the second level and went to the third. And that worked out well for us. The reason we did that was we were coming kind of out of the COVID off years, and we knew we had like a little bit less experience on the team, and we didn't want to bite off more than we could chew. This was still difficult to get done, but it ended up paying off because we got it done in time to get practice, work out a lot of the bugs ahead of time, and we had good success there. All right, 2023. There's a number of robots this year that I think could apply, and I tried to mix it up a little bit, but this is a good example of a team that I think had initially more that they wanted to do, and then scaled back in competition. So this team, they had like a sliding elevator. They could reach out and go do some of this stuff on the higher rungs or the higher scoring levels, but what they opted to do, at least at Wisconsin, was focus on some of the low goal. Just shuttle pieces, put it in the low goal, and it got them picked. They had smart driving, and it was successful for them. But yeah, there's a good example of recognizing they maybe bit off more than they could chew, and instead of spending a lot of time at the event trying to get something that wasn't working, they took what they knew they could do and capitalized on that. 2024. All right, so the kitbot. Mention the kitbot. Everyone know what the kitbot is? First is it's brand new last year. It's kind of expanded on other people's efforts, but this past year was right, just two wheels on one side, and they could direct load from a human player station, and it was good enough. You could pass with this, you could score with this. You weren't going to score in the amp, um, but it got teams working faster, and then teams could take this and expand upon it, which is what 8802 did. They added a ground intake. I think they took away their ability to load from the human player station, but you could always drop it on the ground and load right from the human player then, pretty much. They added a second set of wheels, and then that's about it. So it's basically kitbot on Swerve with the floor intake. And they were the Seven Rivers finalist as the third seed captain. They ignored climbing and they ignored amping. And so this is a bot that I think that you could kind of find a way to scale up. So if you knew for your first event, I want to shoot notes, and once you get that down, you're like, well, I probably have room on the sides here to add a climber. But the climber is separate from the rest of your robot. So if the climber doesn't work, you can at least still shoot. And so if your main goal is get the shooter working, get the intake working, and then if climber works, awesome. Add it on for the next event. Add it on for the off season if you want to. Totally up to what goes back to what your team goals are. 2025. Oh no. Okay. What do these robots have in common?
A lot of them, I see they cut back on unnecessary features or things that they don't want to do, and they prioritize just one thing.
I completely agree. They figure out like what's important to them, and you can do maybe a couple things, but it is probably get good at one thing. What's something that every robot has to have? Like drivetrain. Driving is the most important thing, right? If you can't drive, you're not scoring points. Very, very few occasions where there's an exception to that rule, but that's game dependent, and I would rather have a drivetrain than not. Because you can always play defense. You can push game pieces around. And then you can go from there. We got to have a working drivetrain. What else? I can't remember what I put on this, so we're gonna find out in the slide. But what else did these robots have in common?
I noticed for a few of the teams, they had something that was over-engineered or something that didn't work, and they cut back on it in order to more efficiently do the job it's supposed to.
That's very true, and that's hard to recognize because it can be very easy to love a design that you've been working on and want to spend time getting it right. And it feels almost personal at that point, right? Like you've spent time, or maybe you've got two groups of your team working on different mechanisms, and you've been really trying to get one working. And it can be hard to say, like we put a lot of time into this, but we don't have time to get it working, and we gotta back off and reset. And so that's a tough thing. Very, very hard to do, right? It happens at work too. Like I've put time into projects that end up like this isn't going to pan out, and we're going to have to do the schedule or whatever it is. Usually it's scheduled for FRC, but we gotta back off and try something else. Anything else people noticed? I'll remind myself. What do you got, Jack? They do well in competition. Technically that is a prereq to be mentioned here. But it was probably simple robots that win or achievable all stars. But they did well. That is true because there are some robots that ended up looking similar to these that maybe they didn't do as well. And so the question is what is the difference between some of those? And it might be that the team planned to go simpler sooner, and so they had their robot done earlier than the other team that maybe pivoted to a simple design too late. And that can be right. It's figuring out your timing and recognizing when did we go too complicated. And sometimes you don't find out until the end of the year, and you're looking back now, and you're like, actually, good question here. Who built a robot that was more complicated than they should have when they look back on it this year?
We had our intake,
right? I feel like most people, right, unless you won, champs, right, you probably wish you did something a little bit different. Maybe it's not going simpler. Maybe you went too simple and you thought you could have added something. But it's usually easier to go more complicated than it is to go backwards. All right, so what did I put? used kit or COTS parts. So earlier on, there's a lot of people using the kit apart drivetrain, which was like the way to go. You could get at least if you're trying to go simple, you could get a working drivetrain together much quicker than you could if you're doing a custom drivetrain. This has changed a little bit because everyone's going swerve, and there's not exactly a like kit apart swerve drivetrain. But it's relatively easy to put one together, at least mechanically, because you can buy the kit swerve and you can assemble that. You can cut your 2x1 frame down, but then you got to make sure you can implement the code and everything correctly. But it's getting easier and easier as far as I understand. I'm a mechanical engineer, so I can make sure that they put it together right, but then that goes on to the electrical and software people to get running. So I don't want to say that it's easier for them, but are they in here? Yeah, it's easy for them, right? So yeah, don't spend your time solving a problem that has already been solved. So soup up the kitbot, everybot, or robot in 3 days robot. There's a number of teams that did the Quokka style robot this year. That was kind of like do you guys do that? Yeah, it was kind of like the arm that could tilt up and down. I know there's gonna be a couple here. Who's used a climber in a box or equivalent? They're relatively simple. But like if the climbing challenge is grab a bar and pull up, you might as well just get the kit. Or look at the kit and make it on your own, right? If it's cost prohibitive to buy the kits, but you have the parts to make it yourself, you can at least look at the design, right? The design is out there, the 3D is out there. Many teams have used it, so you should be able to make your own implementation of it if it's the cost of buying it up front that hurts you. They did not try to do everything. That's what you brought up, right? They didn't try to do everything. They focused on at least one thing, and they got good at that. And that's what made them, it's my later point, made themselves useful on a playoffs alliance. So there are some tasks, I think I'll cover the other one. Pivoted to something simpler when they were more complicated route that didn't work. That's also what you brought up, right? Like they recognized that they were going too complicated, turned around, and refocused on something simpler. But making themselves useful in a playoffs alliance, and that's your goal. If your goal is to get picked or to be a captain or whatever, have success in playoffs, you to find a way to be useful. There are some game challenges that don't necessarily translate to being competitive in playoffs. This past year, the trap is sort of like that. Like it's still scoring points, but the biggest value is getting the ranking point, and sometimes it didn't make sense to trap in a limbs. If it was like risky, if you spent too much time doing it, if you could do it really fast, probably still beneficial, but it didn't always translate. And so some of those things are scoring in the low goal. Scoring low goal, if it's just a quantity of game pieces you have to score to get a ranking point, and low goal is easier. There are teams that designed the robot in the 2022 game. I'll go back so we can remember which one that was. I think you had to score like 20 balls or something, whether it was high goal or low goal, to get the ranking point. And so some teams designed the robot to score in the low goal in quals so that they could put more game pieces through. But because points are worth more up top, they then switched to scoring high in playoffs when they needed more points to get the win. Because there was no getting RP in playoffs doesn't give you anything. It used to. There are some games where if you got the equivalent to RP, it translated to a 20-point bonus. First may go back to doing that, but at least in recent games, it has not been that way. What do I have next? Oh, what does every alliance need? I also don't remember what to put in the next slide. What does every alliance need? They need a score. Communication. That's true. Who said communication? Communicate. They definitely need communication. Strategize.
You need something that actually works. You can't just show up to work. You can't just show up to competition with just a mess of metal wiring and all that other fancy stuff.
You do need to work, and so there are. What did I put on here? Working robots. That's number one. That's true. You have to have work. I didn't have stuff about communication, but that is very true. There are some years where there might be a robot at an event that like they only work half the matches, but when they do work, they score a ton of points. And so some alliances may opt to pick that robot because they've got no chance of beating the 1 seed without someone not magically working, but getting lucky and working or figuring their stuff out. But other alliances just need consistency. Like if they want to win, they got to put out at least this many points, and they're going to pick a robot that they can rely on working every match to do that. And generally, how you make sure you keep working is if you get your robot done early, you can then work all the bugs out, figure out where your loose wires are, figure out what are the bugs in the code that cause, something to crash. Figure out where the weak points in your mechanical assemblies are. What are their, what's going to continue to break that you can then iterate on and figure out how to fix so that you're working in every match. Smart driving, that comes from practice. So if you can make your robot simpler and get your robot done earlier and practice, you can get smarter at driving. Compatible autos. This is getting a little bit out of the discussion of like simple robots, but you can have a simple auto like this year, just a shoot and drive. Our team didn't have that, and we wished we had it in some matches. We focused on one auto, and then eventually tried to make our auto compatible with multiple teams. But having just a shoot and drive auto probably should be the first auto that you work on, and then save it, and then keep it in there. Don't overwrite it and replace it with something else. That way, if you do end up on Alliance in playoff, let's say, where you've got two other teams that are doing more complicated autos, you at least have a spot to fit in, because teams are going to want that. You need auto compatibility on a playoffs Alliance. Climbing. This year might not have mattered as much for playoffs, but there are some years where it's like if you don't climb, you have no shot of getting picked. Like if climbing's worth 20, 50 points or something like that. This year it was relatively low. It was only worth like 1.5 notes or less if you were scoring during an amplified period, whereas mostly beneficial for getting the RP. But climbing years like 2022 or 2017, you had to climb, and especially if it's like something real easy, like putting a climber in the box on your robot. That makes you, super useful. Significance of logo, brought that up again. I think we probably covered it enough. But like the amp this year, right? That was kind of considered the logo, super valuable, right? This is probably my favorite implementation of the logo in a year. Whereas some years it is worth just half or a third of the other points, and if you're scoring in there, you've got no shot of beating someone who's scoring just as many game pieces in the high goal. I think that's the end of what I had. I know I rambled a little bit at the end. Any questions or discussions or things people had on simple robots? Who's going to build a simple robot next year? Nice. I hope we do. We built too many complicated robots. Hopefully we keep it simple. 2023.
Overboard and we definitely built beyond our means. We scaled it back this last year.
Was it better for you this year, do you think?
Much better.
Good. It's like the trick is figuring out, it's really hard to evaluate what your own team's abilities are. And it's changing every year. You've got new students, you got new mentors, you have new sponsors and equipment and stuff, and so it's really hard to figure out what is your team capable of. It's always changing.
My team, we were the smallest team at the Wisconsin Regional. So
like robot small or number of people small? Number small. Sometimes it's nice when you get like a nice tight-knit group working on something and everyone always has something to do. But sometimes you wish you had a couple extra hands to do some more things.
Yeah,
I think a thing that we were able to do, but it was very hard, was to get our programmer to like admit that climbing was out.
Oh.
Like we were not,
if it wasn't working, yeah, right.
It wasn't worth going for it at all. Like we need to be able to do these two things well. Like, and we were able to do both. We just had to,
it's tough to sacrifice some of those things and to recognize it, because there's years where you want to do everything. Right? Like, well, you can see how every little part of the game would be important, but if you don't do any of them really well, it's tough to get on an alliance and contribute.
This was my first year